What is hallucination in large language models, and why does it occur? Currently, hallucination in large models is a significant obstacle to their deployment in industry. Efforts are being made to reduce hallucination. First, let's define hallucination. In simple terms, hallucination refers to a model generating inaccurate or nonsensical outputs. These outputs can be categorized into several types. First, contradiction in context. This occurs when a model generates contradictory statements within the same output. For example, if the model initially states, "I like this," but later states, "I don't like this," it creates a contextual contradiction. Second, mismatch with prompt requirements. This happens when the model's output does not align with the specified prompt. For instance, if a prompt asks for a positive review, but the model generates a negative one, the output deviates from the prompt's intent. This could be due to unclear or poorly written prompts. Third, contradiction with facts. This is one of the most common types of hallucination, where the model fabricates facts. For example, stating Munich is the capital of Germany instead of Berlin. Such outputs are factually incorrect. Fourth, absurd responses. These are outputs that are completely nonsensical, such as dogs can fly, or apples are a type of animal. Any model response that fits one of these categories can be considered a hallucination. However, the severity of hallucinations can vary. For example, if a fabricated fact goes unnoticed and is accepted, it could lead to serious consequences. Why do hallucinations occur? There are several key reasons. First is data quality. Large language models are trained on massive data sets, and it's impossible to guarantee that all the data is accurate. Datasets often contain noise or statements that are inconsistent with reality, which can contribute to hallucinations. Additionally, a lack of diversity in training data can lead to hallucinations. For example, if the training data is overly focused on one domain, the model may develop biases, which are another common cause of hallucinations. Second, issues in the training process. Problems in model training can also lead to hallucinations. One common issue is overfitting, where the model performs well on seen data, but struggles to generalize to new data. Third, text generation process. During text generation, the model predicts the next token, based on the tokens generated so far. This process relies on probabilities and includes a degree of randomness, making it difficult to control whether the generated token is factual. There is no built-in mechanism to verify the accuracy of generated tokens, which means hallucinations can occur unchecked. While it's possible to introduce validation mechanisms during generation, this adds significant computational overhead, making it less practical in many scenarios. Fourth, prompt engineering. Poorly designed prompts can also contribute to hallucination. If a prompt is unclear or ambiguous, the model may generate outputs that don't align with the user's intent. Fifth, fine-tuning issues. Fine-tuning is a crucial step in model training. If fine-tuning is not carefully managed, it can increase the likelihood of hallucinations. In summary, hallucinations in large language models stem from a combination of data quality, training limitations, the inherent randomness of the generation process, and issues with prompt design or fine-tuning. Addressing these factors is essential to reducing hallucination and improving the reliability of large models.